this video I will show you a new particle system and this new node, particle output node, and this particle system is for Blender 2.79. So this particle system allow you control the location, velocity, rotation and die times of the particles. Right now this setup and this node for the Blender 2.79, but I'm working on 2.8 version. The problem is the API of the Blender 2.8 is changed quite, so there are many things which are not working properly for this node and this new particle system. So these are the nodes for this particle system, and I name this particle system as a JUGAAD particle system. So this particle system I have tested many times, so it works perfectly except two situations. One is when you want to control these particle properties with animation nodes along with this particle system. In that case it doesn't work. And second is you also want to animate this emitter object with the animation nodes. Then this particle system doesn't work. But if you really want to animate this object with animation nodes, then make the animations and then bake the animations into the keyframes, then it will work. If you want to use this particle system in Blender 2.8, then you can make whatever the effect you want to make and then bake the particle system, and then when you reopen this file with Blender 2.8, then it works perfectly. So this is the first video of the series. I'm going to release more videos about this particle system and this node, and in this video I will show you two forces. One is curve guide force, new curve guide force, and vortex force. And in my coming video I will show you more forces which you can use in this particle system to control the particles in Blender. So let's get start with basics, and then I will show you a more advanced example with this particle system. So when you download the zip file, then it has two folders, basics and advanced. So first one is for the location. So this is a very simple particle system. Particles are emitting along the x-axis. So I want to affect the y position of the particles. So offset the location of the particles with this offset vector node, and when we change this file of parameter, file of input, then we can see that these particles are going along the y-axis. There is one crucial thing is when you are using this particles output node for location, velocities and rotation, then enable these three options. And when you want to use die times also, then enable these four options. Otherwise it will give you an error message. I will just show you. Suppose if I see, this is showing the error message. So you have to enable these options accordingly. So if we want to only affect the particles which are near to this empty object, we can use the fall off node. So this particle system is working like this. At the first frame we have this position, and this is, if I use, we have these positions of the particles initially. So this particle system is working like this. At the first frame we have this position of the particles, and then we modify this location of the particles, and in the next frame we have this modify location of the particles, and this modify location also updated here. So each frame this loop is updating, basically this cycle is updating, and this is how this particle system is working. So next I will show you for the velocity. Okay, just to make it simple, we have same particle system. Now I want to move these particles along the z-axis. So I'm offsetting the velocity of the particles with this offset vector node, and see these particles are going along the z directions. And if we want to only affect the particles near to this empty, we have to first evaluate the fall off. Then I use custom fall off node to convert back this data into the fall off. And now we have this effect. Only particle near to this empty are going along the z directions. So to modify this location velocity, we can use this offset vector node, and we can also use this vector mix node. And next is rotation. So these particles are going along x-axis, and one point is this rotation input for this particles output only use quaternions. So if you are using Euler or floats, then you first have to convert this into quaternions, then plug this into the input of this node. So here I want to affect the particle rotation with this empty, and in particle system you have also enabled this rotation option. Otherwise it will show you in viewport, but it doesn't during rendering. So keep in mind this to enable this rotation option while using this rotations. Next is die times of the particles. So let us make it simple. Okay, so here what I'm doing is we first evaluate the fall off at the particle position, and this has this values. The particles which are inside this area has 0 value, and outside it has 1 value. So if we multiply this with the diatimes of the particles, then basically we are making the age of the particles which are in this area 0, and that's why these particles are not appearing in near to this empty. And we can also combine to fall off with this mix fall off node, so we have this effect. So these are the 4 basics examples for these 4 options. Now I will show you a more advanced examples with this particle system. And in this example I want to affect the particles with the sound. So here I have this sound. So if I play this, see, it's affecting the particles. The setup is very simple. You first bake the sound and then use sound fall off node, and this node I want to just control the effect of the sound on the particles. And then I use this offset vector node, and I'm offsetting this location with the same value. So whatever the location I initially have particle is going in same directions based on this sound. And this is a group node, and there are a bunch of more nodes available in this particle system which I have created to control the particles. So one of this is velocity from location node. So we have this new locations of the particles and we have this previous one. So if we subtract them, then we get the velocity. So this group node is basically doing this for us. So then I'm this calculated velocity I'm mixing with the existing velocity of the particles by this 0.5 factor. So in this way we can control the particles with animation nodes. Okay, yeah. So in this example I want to displace particles with this empty. Okay, so this is the previous node which I showed you. So suppose I off the velocity, so we have simply this effect. So in this example I first offset the location of the particles along y-axis, positive y-axis, and then inverse the offset vector, and then if we use combined effect of this, we are offsetting the particles along the y-axis and negative y-axis. Make this drag force, I use another offset vector and offsetting the location with this previous locations by this vector. So if we combine these 3 together, we have this effect. And in physically correct to this, because we are changing the particles location non-linearly, so there should be a velocity gradient. So that's why this node, to get that effect. So we can see in velocity color there is a change in velocity. Okay, this is also the same example, but in this example I want to affect the particles with this curve object. So same setup, I first displace the particle along the y and z axis and then use this offset vector to give this drag effect of the particles. So if I play this, it looks like the particles are colliding with this object. So drag is very simple to achieve this. Suppose if I select this object and okay, these particles are going along the positive x-axis. So if we offset the position near this object of the particles along the negative x-axis, we are basically making a drag force. So we can control the effect of this drag force with this offset vector. Yeah, this example has very large number of particles, so I bake these particles. So I want to affect along the z-axis with this curve object. So curve object has this oscillatory motion, and then I use this curve as a fall off object, and then offset the location of the particles, and then calculate the velocity from this new locations, and then plug into the output particle node. See, we have this effect. So nice thing with this is we can make different shapes like countdown or something. And the next example is vertex force based on position. So this is similar to this vertex force, but in this I want to achieve this effect, means particles are going toward the center of. So in this example I first normalize the location of the particles which are starting from this circle, and then I use this vector math node as a cross product. So this node is basically deciding the symmetry axis. In this case is z-axis, and then I offset the location of the particles, and if I simply use this, we have this, which is the same we have in Blender vertex force. But to drag these particles toward the center, change the fall of this vertex force. So I first calculate the length of the offset locations, and range is 0 to 30, and then I offset, means output is max is 0 and output minimum is 0.95, means it has starting from 0, as it is going inside it has maximum rotation. And if we use this map range node to map the scale of the position of the particles, we have this inward vertex force. So we can use this for a accretion disk around a black hole or to make a galaxy very easily. And the next example is, this is also the same vertex force but now based on the velocity of the particles. So in this case I am only affecting the velocity of the particles, not the location of the particles. This is same setup. I can offset the location of the particles based on this cross vector math node, and then when we subtract this new location from the previous location, we get the velocity, and then I mix this velocity with the existing velocity of the particles. So if I just remove this fall off node, we have this vertex force, the particles going toward the center. So we have only the noise force, which is here, this one, and if we make this fall of 1, we have the full curve force with the effect of also in this noise force. And I forgot to mention one thing, and these offset of the velocity or location or other rotation and items also include the effect of the forces which already have in Blender. So you have to mix accordingly. If you make this factor is 1, then it is only going to use this new forces, and if you mix half and half or less than 1, then it also include the effect of the external forces. If I make this 1, we are very fast. It is so fast, it's going inside and then bouncing back. And if we want to change the symmetry axis, in this case is z axis, suppose I make this y axis, see, we have this effect. And we can use even object to control these. And suppose we have this and we have x-axis, or we have this tilted spiral effect, see. So we can do many things with this particle system. And the next is curve guide force. We also make this animation because I am recording on my laptop. So this we have this curve guide force in Blender, but the problem or limitation of this force is that if suppose particle born at this location and it has to complete this entire length of this curve in its edge. So if it has small edge, then means it is moving very fast, and if it has larger edge, then it is moving slow. So we can't control these particles or affect this particle with other forces. So but this new curve force allows you to control these particles very easily, and there is a duration time to complete this curve, and this is set for all these particles, so it doesn't depend on the age of the particles, means. Okay, so it take the burst time of the particles, then the curve object, that you want the particles to follow, and this offset curve end means to complete the half the curve or full curve. This interpolation allow you control the velocity of the particle along this curve object, and duration is the time to complete this curve. So here I am using this vector list mixer node. There are two of these. One is just you can use this mix factor, and another is fall off. So there are two of them. So then when the particle reaches this point, I'm making this force is 0 at this point. This particle is then affected by this noise force. Then we have this effect. And the next example is also for the curve force. So same things. So here I parent the emitter object with this curve, and at the starting of this curve, because this is a Bezier circle. So if we use evaluate node, then we can find the starting of this circle, this Bezier circle. So I parent the emitter object here, and then use this mixer node to mix this curve force and this effect of this external forces by 50/50s. So it is affecting, and these particles affected by these forces and also by the curve force. Animating this force object with keyframes, not with animation nodes. As I explained previously, it won't work if we animate this with animation nodes. We have to bake the animations into keyframes. So these are the advanced examples for this new particle system. And probably you notice this, I have used this AN prefix for this node groups, and if the node group has this AN prefix, means it is for you, you can use in your node network. I made this for you. And if suppose they don't have any AN prefix, then it is not for you, it is for the internal node network. So because those which has this AN prefix, I name them properly. And suppose there are nodes which has this AN with the asterisk sign or a star, you can also use those node groups, but be careful, because those node groups only works in certain conditions, in certain situations only. So I use these conventions in my previous node groups also, which I released, like point scatter node group or liner. So keep in mind these conventions while using these node groups. All the download links are available in the video description, so you can download this particle system and this node and examples. If you have any query, doubt, then you can ask me in comment section, or you can also ask me on my Twitter account. So if you like this work, please like the video, share the video, and subscribe to my channel for more updates. And I'm going to make more videos about other forces, and because in this node you can only control the location, velocity, and rotations, and I'm working on other nodes to control the other properties of the particles like size and other things. So that when that complete, I also release those nodes. So happy noding.